Hello, everyone. My name is Ben Harper, and I'm the National Sales Manager for Pilz Automation Safety, and I'd like to welcome you all to this training. Today, we'll be covering the Pilz PSENscan Safe Laser Scanner, and our presentation will be given by one of our regional sales managers, Doug Berkmeyer. As a reminder, this is part 14 in a series of trainings we're conducting on Pilz products and services, as well as some coverage of general safety standards and practices. I hope you'll all plan on joining the full series of these trainings, and I hope that they'll prove to be valuable to you in learning more about machine safety and how Pilz can help you achieve your overall machine safety goals. And with that, I'll hand it over to Doug Berkmeyer to begin our presentation. Doug?
Thank you, Ben. And hello, everyone. As Ben mentioned, my name is Doug Berkmeyer, one of the regional sales managers. Today, we're going to talk about our line of safety laser scanners, as Ben mentioned, also known as the PSENscan. Topics that we're going to be discussing today are our line of safe sensors, description of the PSENscan, the versions that we currently have available, some of the benefits of using the PSENscan, as well as some product details and some application examples. And at the end, we're going to go over the software configurator. For those of you who are not familiar with Pilz and our portfolio of sensing products, this is just a general overview of some of the sensors that we have available. Some of these have already been discussed in previous webinars. We have everything from the basic RFID or magnetic switch up to magnetic locking switches, light curtains, and our PSEN radar device, as well as our safety laser scanners that we're going to be talking about today. The PSENscan laser scanner is a two-dimensional area monitoring device. It is suitable for applications up to PLD, Type 3, and SIL 2. We currently have 4 versions available, being the base model, a light model, and a combination master-slave model as well. Depending on the versions that you choose, you can have either a 3-meter or a 5.5-meter safety zone. All versions have a 40-meter warning zone. All versions also have up to 275 degrees of protection, and they have a resolution of either 40 or 70 millimeters. Each one of these devices can monitor 3 separate safety zones. And those zones will become either a warning zone, a protection or a safe zone, or a reference zone. Currently, we can monitor 1 protected or safety field at a time. As you notice here, there is an asterisk, and in this parentheses here where it shows 3. There is a new version that I'll be discussing quite often through this presentation that will be coming out soon. That version will allow you to do up to 3 different protection fields at one time. Currently, we can do 10 different zone configurations with our scanners. But again, with the new version, you'll have up to 70 different zone configurations possible. The reaction time of the PSENscan is as low as 62 milliseconds, and it has an IP rating of 65 for your protection. Some additional features with the PSENscan with the light version or the master-slave version are the muting capabilities, EDM, which is the external device monitoring. There is an override function. There's also the capabilities of doing reference point monitoring, and you can also use these scanners in vertical applications. Start off with the base version of the scanner. Again, has 275 degrees of protection, has the same resolution, but the main difference with this one here is it has an M12 8-pin connector on the back side, and that is the only connection that you have with the base version. It allows you to have 2 OSSD outputs, 1 signaling output that you can use for a warning zone or a muting lamp, and it also allows you to have 2 safe inputs, and it also has an additional input which can be used either as an input or an output. The light and master-slave versions are all very similar, and these here actually have a resolution that is selectable of either a 40 millimeter or a 70 millimeter resolution. That will definitely help you fine tune your application. The new version that is coming out, as you can see in parentheses here, allows you to go down to a 30 millimeter resolution, but it's also selectable for either 50 or 150 millimeters. With these versions, they both have two different sets of connections on the back. They all come with a 12-pin or an 8-pin connection on the back side of them. You do not have to use both of them. It's just simply one or the other. And the only difference is it depends on how many inputs and outputs that you need for your configuration. So if you don't need very many, you can use a lower cost cabling and go with an 8-pin version. As you see in parentheses, with the new version coming out, it will be a 17-pin connection. All of these, again, are 24 volts, and the inputs and outputs all depend on the number of cables that you have, depending on which pin configuration you choose. Each one of these scanners has a removable memory module. The memory module is used to save your configuration on your scanner. If something happens to one of your scanners, happens to become damaged, you can simply take the bottom plate off of the scanner, unplug the memory module, and plug it into a new device. You do not even have to take off the cabling off the memory module, because this is where your 8-pin or 12-pin connections will be. You do not have to remove the cabling. You do not have to have any sort of computer or software. So all you simply do is plug in the memory module, and when you start up, it does a self-test, and your scanner is good to go. Another feature that we currently have available, again with the light and the master slave version, is what they call reference point monitoring. Reference point monitoring is a safety function used to monitor any change in position of the scanner or a structure. With the reference point monitoring, the reference points must be located outside of your safety zone, and the structure that you're referencing can either allow or prevent access to a danger zone. As it says here, the national and international standards highly recommend reference points for all vertical applications. Here's an example of some reference point monitoring. As you see here, we have a work cell with a guard around the outside, and it actually has an access door. Inside the work cell is a laser scanner, and you have your red safety zone drawn in here. The reference points would be these 3 black dots, and what that is doing is that's actually pinned to the actual door when the door is closed. What will happen is if the door is open, those reference points will no longer see the door, and your OSSD outputs will turn off. This is another example of using reference point monitoring, and this will be a vertical application. So here we have a protective structure on the left and the right side. This could either be a wall or maybe a fence. PSENscan is mounted overhead, looking down towards the floor and guarding this access area. With the vertical position that we have here, what you would do is you would actually pin 3 different reference points on each structure around the safety zone. If something would happen and, for example, maybe this fence was removed and someone would try to just use this as an access way, this I, H, and G pin that's on here as your reference points will no longer be visible, and again, your OSSD outputs would turn off. This is great either if the structure is removed, or if something would happen and the scanner above happens to become bumped or misaligned. You're thinking that it's looking straight down on the floor, but it might be looking off at a 45-degree angle. If it's doing that, then you're no longer guarding your access way like you think you are. With the new version of the scanner that's coming out, you can do up to 3 separate safety zones at one time. As you see in this example here, we have one safety scanner monitoring zone 1 and zone 2 simultaneously. This would be a great feature anybody who has a multiple work cell like this. So if the operator would walk into zone 1, the sensor would see that he is in zone 1 and shut down this half of the application while allowing the other half of the machine to continue to run. And this would definitely increase your productivity by not shutting down the whole machine. The only way you could do this previously was to have two separate laser scanners, one for zone 1 and one for zone 2. So just using this new feature will allow you to cut your costs with just one scanner. The other configuration that we could have with the master slave version is you can basically daisy chain up to 4 scanners in one line. So the first one would be your master. This is where your main power and your main I/O would come into. Each additional one, you can have up to 3 more slave devices here, would all be used with just one cable going to each one. This would definitely help in cost and in your configuration and your setup time. You do not have to have individual power and I/O wires from each individual scanner running all the way back to the control panel. Again, all that goes through one cable back to the master, and all your I/O comes from the master back to the control panel. In addition to that, Pilz now offers ROS packages for your application. This would be used for productive area monitoring and dynamic navigation of an AGV. Using ROS packages, the scanner can actually provide the raw data to the ROS compliant operation that you're using. And you can actually use that for navigation for any type of application, for example, like with SLAM. So if you're familiar with ROS packages, you're probably more than likely familiar with SLAM, which is simultaneous localization and mapping. The ROS packages are available for the master version only. And as you see down here in the bottom, the ROS code is on this website. So if you're interested in using this scanner for your ROS application, I highly recommend going to this GitHub website that we have listed here. All the code is already there for you. You can easily copy it and paste it into your existing application, as well as some other application examples on that website. Again, the ROS packages, as it says here, is easy to integrate safety scanners into your existing ROS environment. As it shows in this example, you can use multiple laser scanners with ROS, and the AGV navigation can be used with SLAM or any other application that you might use, for example here with the laser scan. It is compliant with the Pilz software development, and as I mentioned earlier, the development team is constantly changing this and constantly updating. Again, I would highly recommend going to this GitHub website, find the latest and greatest in applications and the existing code that you can use. A few examples of the use the laser scanners. As you see here, we have a robotic work cell with a turntable. In this application, they're actually mounting the laser scanner underneath the turntable, and they have drawn in a red safety zone and a yellow warning zone. So anybody who approaches the turntable into the yellow zone, you can either have an indicator light to sense that a warning signal, or you can maybe slow down the operation maybe to a slower speed. Once you get into the red zone, then you can actually stop the operation safely. This here is the exact same work cell. However, instead of monitoring the outside, they're showing you how you can monitor the inside. So this will be used if someone would happen to be inside the robotic cell, and maybe somebody would walk up from the outside, not notice the person inside the cell. They try to start the robot cell, and that could be very hazardous. With the laser scanners on the inside of the cell, that would protect you from restarting this machine because it would detect someone inside. This is an example of using the laser scanner in a vertical application utilizing muting. As you see here, this is a walkway. One employee can walk through here, but also a conveyor belt for product to come through. The laser scanner is mounted in a vertical application, scanning this whole area, allowing access for the individual containers to come through, again, utilizing the muting function, but limiting the operator to go through. And if they do, again, you would shut down similar to like what you would with a light curtain. We've talked about this already, but then again, this is a application here to where you can use the laser scanners on an AGV, again, utilizing the ROS packaging. And again, you can use it with lots of different devices, lots of different applications. Again, here they're talking about using it with the SLAM algorithm. And also you can use that to help, with SLAM will help you with mapping your environment and being able to avoid any type of collision with your AGVs. These are just a few more AGV examples. With a Pilz safety scanner, you have 275 degrees of protection. So as you see in this AGV application, you're only using 2 safety scanners. So with a 275 degree protection, one safety scanner can do 2 sides, and the other one on the opposite corner can do the other 2 sides. Again, cutting down the cost of the number of scanners that you have to use for one application. This one here, application is utilizing the zone switching. So if the AGV is moving forward, you can have it set for zone 1. So maybe you're just looking straight forward. But if you happen to turn to the left or right, you can change your zone configuration to be in an angle so you can detect off to the side to make sure that there's not going to be any collision versus just checking the front. And another AGV application here with the PSENscan, it does provide all the raw data, but you can also use that data for distance measuring. So here the PSENscan is actually going through and trying to find an open space to put this container. So utilizing the raw data from that scanner in your ROS environment, it's actually measuring the distance and finding an open spot and allowing you to use that for your cargo here. This is just a simple breakdown of the part number configuration. As you can see, we have several different versions. The ME will be the new master encoder version, which will be the 17-pin version that will be coming out later this year. These are a few of the accessories that we have available. Again, if you need to replace a memory module for some reason, we have those. We also have a variety of different brackets. We have some fixed brackets here. We also have some brackets that are available. The P is for pivoting, allow you to pivot your scanner up and down, or pivoting and rotating. You can definitely fine tune your application. Again, this is a breakdown of the part numbers that are available and the actual Pilz order item number that's available. The 6D00 numbers here, so the actual order number that you would use to place your order. All of these can be found on our website. Again, this is some more of the same part number for the accessories that are available. As a quick overview of some of the benefits that we talked about, again, all the scanners have a large 275-degree operating range. You can select either a 3-meter or a 5.5-meter sensor. It's very easy to integrate into your existing application with the compact housing, and you can freely configure your warning zone and safety zone, which I'll show you here in a minute when we get into the software. Again, with the new version, you can simultaneously monitor up to 3 separate zones, and you can have up to 70 different configurations. And if you're utilizing the master-slave configuration, you can wire these scanners in series, and again, have one cable going back to your main control panel. The integrated display, which is on the front of all the scanners, is great because it tells you if it is a safe zone, if somebody has approached the warning zone, or if there's any type of error, it will list that and the error code on the front screen. And again, you have the transferable, the memory module. If anything happens to your current scanner, it's very easy and very quick to replace that memory module. And last but not least, it's very quick and easy to configure this whole system using the PSENscan configuring software. Speaking of that, I will do a quick overview of this PSENscan configurator. When you first start up the software, you will have a home screen looking similar to this. On the right-hand or the left-hand side, you have the online help, which will help you get started if you're not familiar with it. If that screen is not there, when you get further into the software, you can always click on the little screen on the top with the little question mark. So as you can see here, you can create a new configuration, open existing configuration, open existing report. So for example, if you wanted to monitor an existing system, you can just select that. And when you do, you can scan your network. If you're connected to it, you can scan your network. And in this example here, we have a master device, and the master device has one slave connected to it. One of the great features with this software is if you're not familiar with the layout, or if you're not familiar with which scanner is which on your application, you can click on this little icon, looks like a light bulb. Once you click on that little icon, the front screen on that specific scanner will flash. So if you're not sure which scanner is which, you can simply just click on the light bulb and the screen will flash and tell you which one you're using. Again, if you're back to the main screen and you want to create a brand new configuration, just simply click on that. That will open up a window that has all the available products to date. You do not have to have different software. The base version has a different software, but the master slave version and the light version all utilize this same software here. You can simply select which version you want, and that'll take you to the general properties. General properties is very similar to most software. You can type in the name of your program, the author's name, a brief description. It also gives you a time date stamp down here as well. This is a screen where you actually select if you're going to use an expert or vertical mode. Expert is just a basic horizontal mode, and vertical would be like we talked about previously, where you're mounting it in a vertical application. And here you would also select which type of pin configuration you're going to choose, either the 8-pin or 12-pin. Again, that would determine how many I/O points you're going to have available to you. Once you do that, the next screen will be your output configuration screen. Here you can determine if you want to use a warning zone or not, or if you want some sort of a warning light or warning signal to come out of the scanner. If you have any sort of alarming or muting function. So if you want to use muting, you would enable the muting here. As you see here, this will be your pin configuration. If you're using the Pilz cabling, the color code here coincides with the existing Pilz cables. So in this example here, the OSSD 1 and 2 are already configured for pin 5 and pin 8 for the pink and gray wires. The other ones, which are not grayed out, they allow you to have this little drop-down window here, and you can choose which pin and which function you want that pin to have. So the example here, if you wanted the override status or a warning light, you can select that right here on this configuration screen. The next screen would be your configuration of zones. If you're only using one zone, you don't have to do anything from this screen. You can just move forward. However, if you want to use multiple zones and you want to be able to switch those zones, you can just simply increase or decrease the number of zones you have here. And then over here on the side, it will allow you to have a little drop-down window. This example here, it says area switch 1 for pin 3. That would mean I am in zone 1. And pin 9 is configured here for zone 2. Next screen, you configure your additional inputs that you have available. So in this example here, you can select the type of restart that you're using with this configuration, if you're using any type of EDM or not, and allows you to do either a unidirectional or bidirectional muting. If you are using muting in this example here, I have a couple extra inputs that are available. You see again, the top ones are grayed out because they're already being used. Now I have a couple of outputs down here, or excuse me, inputs down here that I can select. My muting sensor number 1 or my muting sensor number 2 can be tied in with this PSENscan. Next screen is where allows you to come in here and change the number of scans, how many times the scanner will sense something before it faults. And it also allows you to choose your resolution. This is like I told you before, you can either have a 40 or 70 millimeter resolution. You're allowed to change it here on this screen. You can change it in the safety zone and also the warning zone both. That will take you to your zone configuration screen. This just basically gives you a sample or a picture of a laser scanner here, shows you the 275-degree radius, allows you to choose different types of drawing tools, either a circle, ellipse, freehand, or linear tool. Over here in the far left-hand side, you can see your configuration. So since I have chosen to do 2 zones, it allows me to have 2 zones here that I can draw in independently of each other. So here I selected zone 2. I can simply come in here and I can draw in my safety zone and my yellow warning zone. If I come over here and I switch to zone number 1, I can have a completely different configuration by looking at that zone. Again, I have a red safety zone and a yellow warning zone. The final thing that you have here is your reference points, which I mentioned earlier. The reference points, you simply select your reference point indicator, and then you see the green dot located up here. That is your actual reference point of what you're using as a structure, the door or the wall, the fence. And with here, you can actually select the tolerance. And what is the tolerance of the vibration you're going to allow that to move before it trips. Once you save your configuration and download it to your scanner, you're actually going to go into a live monitoring mode, as you see here. You have your simple scanner configuration down at the bottom, and anything that is gray is a wall or a structure. If I come down here to the bottom left, I can actually select my diagnostics indicator, and this window will pop up and now allows me to look at every single input and output I have on that scanner, and it also shows me the status. So whether area switch 1 is on, my OSSD outputs are on or off. It also allows you to come in, if you're in the zone monitoring, you can actually click on the back arrow and come back to the zone configuration screen. So since I'm live and I backed up to the zone configuration screen, now I can see my walls or my door that I'm looking at. This is great for when you're using the actual reference point monitoring, because as you saw on my first screen here, it's kind of hard with a blank screen to know exactly what that reference point is going to be, especially within that 100 millimeter tolerance. So if I'm on my configuration screen here live, I can definitely pinpoint where those reference markers need to be and where the wall is located. So once I configure that, I can save it again and then definitely be within my tolerance. So here it's showing you that I'm actually have 3 reference points again on the door. If the door would happen to open, as you can see, it's no longer there. The reference points are no longer tied to it. You're going to get a big message right here on the software that says reference point. That's going to be the same message that's going to be on the front screen of your scanner. But you also notice that the OSSD output here is red and it turned off. You can also notice that here on the side where you're looking at your I/O. Both reference points are, the reference point is no longer there, so both OSSD outputs are turned off. The last thing I wanted to show you real quick is the reporting that you can do. This is just a sample of the PSENscan configurator reports. Again, very similar to a lot of software. It has your username, the checksum, creation date, but it also gives you your I/O pinout and how you have that configured, as well as giving you a sample of what your zone configurations are set up as. So it's definitely a great tool to have. You print that out, stick it inside the control panel for any maintenance personnel. Look at that. And with that, that is all I have for right now, and I will turn it back over to Ben Harper.
Thanks, Doug. I appreciate it, and very well done. For anyone who would like some additional information on the PSENscan product line, please feel free to reach out to your local sales engineer or your local Pilz authorized distributor. If you're unsure who that is, I recommend reaching out to our inside sales team at insidesales@pilzusa.com, or they can be reached at 734-354-0272. Thank you very much, everybody, and have a good day.